right. Welcome everyone to
Switch
the
back
DBA.
to the screens and to the slides.
Sorry.
There you go.
All right. Welcome everyone to the DBA Fundamentals group, virtual group for November. Today's presentation is entitled An Introduction to Partitioning. It's going to be presented by Andrew Pruski. I'll be turning things over to him in a minute, but I got a few things to go over first. My name is Kevin Wilkie, and I'm standing in for Steve Cantrell, the chapter leader of the DBA Fundamentals virtual chapter. You can send us questions by emailing us at dbafundamentals@pass.org. Here's one of our slides on one of my favorite sponsors, Century One. They have some great information. They have great downloads, a lot of great things you need to check out because they're very helpful. Also, they have great videos. I know I tend to use the Plan Explorer on a lot. It's great, and also I get a lot of great advice from the answers.sqlperformance.com from them, and they're very helpful. They do a lot of work with SQL Saturday, a lot of work with on Twitter. They're very helpful. Also, one of our newer sponsors is DB Watch, database control. They do a lot of work with administration and license management and performance tuning. They have also helped me a couple times finding out new things to work with on DBA side. As we all get more databases, we have found more things to work with, and they have actually been able to help me as well. Here we have our all of our people who actually put together this great virtual chapter. It's Shane and Steve, Glenda and myself. We're always available for any questions you may have. Or you can actually just ping us on our Twitter for DBA Fundamentals. That works as well. Or you can hit us up on Slack channel, which is at sqlcommunity.slack.com, which is how you get to it. Also coming up very soon is our virtual group webinars. As you see here, we have one coming up very soon for Women in Technology using Azure Databricks with Ginger Grant. That one I'm actually looking very forward to because we are at the company I work at. We are fully in Azure, so I'm looking forward to learning more about Databricks themselves. Also, very soon is professional development is giving a one with Jess Borland on busy as a four-letter word, which as a DBA we all know very well. So I'm trying to get more calm with that. So we're working on that. We also have, especially for the DBA Fundamentals group here, we have Jess Promfret coming up very soon with Data Compression 101. That will be next month, which is coming up rather soon. So everybody please be aware of that and hopefully come join us for that wonderful session because I know I'm looking forward to that. Also coming very soon, I don't have a slide for, is SQL Saturday. There is one coming up very soon in Washington, D.C. That will be here in the next couple of weeks. And also in January, there is a SQL Saturday for Nashville, which hopefully I will get to go to this year. That is my plan anyway as of right now. Hopefully I'll be speaking at it as well. Also, we have our virtual groups, which there are many. We speak on many topics within PASS. There is one on virtually every different group that you can think of that having to do with databases and professional development. Also, there are many for different languages. So I am sure since you're coming to one of our virtual group meetings, hopefully you will come to some of theirs as well, because I have learned a lot through many of these virtual groups. Please be sure to come to as many of these as you can. They're always very helpful, and are always willing to help as much as they can. So with that, this session will actually be recorded, and it is usually available within 1 or 2 days. Usually, that's what we try for anyway. After those couple days, you can always view this session at the sites shown there, fundamentals.sqlfast.org/meeting archive, or you can go to our YouTube channel at DBAFuntube.org. And with that, I switch over to Andrew. And let's see, make him the presenter. So with that, Andrew, are you ready?
I am. Thank you very much. Okay. Welcome, everyone, to this session on an introduction to partitioning. A little bit about myself. My name is Andrew Prosky. I'm a SQL Server DBA and Microsoft Data Platform MVP, originally from Swansea, Wales, but I've been living in Dublin, Ireland for about 5 years now. My Twitter handle and my email address are up there at DBAFromTheCold and DBAFromTheCold@gmail.com. So if you have any questions after today, please feel free to get in touch. I'm always willing to talk about this stuff. My blog's there, DBAFromTheCold.com. Posted multiple articles about partitioning, some of which I'm using to base this session on, and some of which go into a little bit further information. So if you want to check those out, you are more than welcome. And then finally at the bottom there is my GitHub account, github.com/DBAFromTheCold. All the code and the slides for this session will be on there, and I'm sure I'll upload to the DBA Fundamentals group as well. So all the content that you'll see today will be available to you. So on to the session. Partitioning, as we know it, has been around since SQL Server 2005, and there have been various updates throughout the years. SQL Server 2012 gave us by default 15,000 partitions. SQL Server 2014 gave us the ability to rebuild an individual partition, and the biggest update came in SQL Server 2016 SP1, where partitioning went from an enterprise-only feature to being available in standard edition as well. So it's been around for a while. And because of that, I think that partitioning is a core DBA developer skill. Every DBA developer should know the theory behind partitioning, how to implement it, and how to maintain it on an ongoing basis. And that's what this session's aim is to give you a base of knowledge to work with partitioning in SQL Server. So after this session, you can go away and start building a partitioning solution for yourself. So here's what we're going to cover. We're going to start off with the partitioning definition. What is partitioning? And then we're going to talk a little bit about the benefits and the drawbacks of it, but I really want this to be a demo-based session. So we're going to get straight into choosing our partitioning key, which is the column on our partition table that defines our partitions for us. Once we've got that, we'll then have a look at partition functions and schemes, the objects that we build partition tables upon. Then we'll have a look at indexing considerations, because there's a couple of little gotchas that we need to be aware of when applying indexes to partition tables. Once we've done that, we'll then get into the specialist operations that we can apply to partition tables, the split, the merge, and my favorite operation, the switch operation. After having a look at that, we'll then wrap them all together and put them into what's called a partition sliding window, which is just a method of extracting old data out of a table and importing new data in on a rolling basis. And then we'll have a look at something that people might not consider with partitions, but file group restores. If we spread our partition table across multiple different file groups, we can, in the event of a disaster recovery situation, reduce our recovery time by only restoring the partitions that we need. And then to wrap up, I like to tell a story at the end of this session, I like to tell it because it's 100% true. And it happened to me earlier this year, where a friend of mine implemented partitioning on a table, hadn't put any maintenance together, and so we had to go and fix that. And it happened one March evening in a pub in Dublin. So I'll wrap up the session by telling you that story, because there's a nasty little gotcha there as well, which caught me by surprise. But first things first, what is partitioning? Now, partitioning is a way of splitting a table up horizontally into different units, partitions, that can be spread across multiple physical locations. So we're in essence dividing our table up. We can have up to 15,000 partitions per table, and each one of those partitions can have a specialist operation applied to it, which increases the manageability of our data. Now, I stress manageability of the data because that is what partitioning is primarily for. It's primarily for the maintenance of data. I have seen partitioning improve query performance, but I've also seen it annihilate query performance as well. You need to be very, very careful if you are implementing partitioning on a table thinking you are going to get a performance boost, because a lot of the times it doesn't happen. So why would we want to implement partitioning on our tables? Now, the top one there is fairly obvious. The partition tables themselves appear as normal tables in SQL Server. We don't need to do anything else to tell our queries coming in that they are dealing with a partition table. Data will automatically be mapped to the correct partition as it's inserted to our partition table if we have set it up correctly. I've already mentioned we have specialist operations that allow for easy management of our data. We can use things like the switch operation to move large amounts of data in a metadata only operation from one table to another pretty much instantaneously. Very, very handy when it comes to importing and archiving data. Individual partitions can be compressed, saving us a bit of disk space, and individual partitions can be rebuilt, saving us a little bit of maintenance as well. Of course, there are some drawbacks to partitioning. Now, the first one there requires management of the partitions and the file groups. Once we set partitions up, there's nothing inbuilt in SQL that automatically manages our partitions for us. We need to build something, usually a stored procedure, running as a SQL Server agent job that will manage our partitions. When I say manage, I mean create new partitions for us and merge old partitions for us. Otherwise, if you don't do that, you're going to end up with one big partition with all your data in it, and you're going to have to work out what you're going to do with that. The specialist operations that I mentioned there, they can be blocked by DML operations. So if that happens, you will end up with severe blocking on your system, and you'll have to try and work around. So you need to be a little bit careful when you apply those operations. You can have foreign keys referencing your partition table, but if you do that, you will lose the ability to perform the switch operation and therefore lose a lot of the power of partitioning. And the final point there is a pretty big one. The performance of your queries that do not reference the partitioning key can and will decrease. You need to be very, very careful when you are partitioning your table. You need to know the queries that are coming in and how they will be affected by implementing partitioning on an already existing table, or if you're building a new table, it's a little bit easier because you know what's coming and you can design around that. But just be aware that partitioning can have adverse performance effects on your queries. Okay, I really want this to be a demo session, so let's go diving in and let's start building a partition table. So the first thing we need to do is choose our partitioning key. Now, this is the column in our table that defines our partition boundaries. It essentially says how are we going to divide our table up. So we need to think about things like how are we going to split the data? Do we have any archiving or retention policies for that data? And how is that data going to be queried? Now, I really wish I had some sort of golden rule that I could give you for this, but unfortunately not. The only thing I can say is know your environment. Know the data, know the trends of data, know how it's going to be queried. And therefore, you'll be able to make a reasonable decision when it comes to picking your partitioning key. And we do have a lot of options available to us. We can use pretty much all different column types, apart from things like timestamp, end text, varchar max, varchar binary max. We can even use a persisted computed column if we want to. So that is choosing your partitioning key. Moving on, once we've picked our key, we can then go ahead and build our partition function. Now, the partition function is the object that maps rows in the table to an individual partition. And it's really simple syntax. We just say create partition function, giving it a name, specifying a data type that is the same type as our partitioning key, as range right or left. Now, this is how our partition boundaries work, and I'll talk about that in a little second. And then we say for values, and we specify our initial partition boundary values. Talking about the range right or left, this is how boundaries are applied to our partitions. So if we said range right, and we have partition X there, that partition, say it's a date type, would have data in it from the 1st of the 1st, 2017, all the way up to, but not including, the 1st of the 1st, 2018. So that one partition there would have a year's worth of data. However, if I said left range type, the partition would have data in it not from and not including the 1st of the 1st, 2017, all the way up to and including the 1st of the 1st, 2018. So there'd be an overlap of a year's worth of data there. And for that reason, I would always recommend using a right range type when working with especially date times with partition functions. Now you need to be a little bit careful because as range right or left is an optional feature, you don't have to add it in, and the default is, of course, left range types. Another thing to be aware of, and I'll mention this in the demos a little later on, that there is a little bit of a gotcha when it comes to working with right range types, and I'll show you that in a demo in a second. But that's our partition function. We have our partitioning key, we have our partition function. We can now build our partition scheme, and this is what maps partitions to file groups within our database. Now, in my opinion, this is where partitioning starts to show how powerful it is. We can take one table and split it across multiple physical locations. So we just say create partition scheme and give it a name, as partition to our function, and then we specify our file groups in order of the boundaries that we set. Now we do have the option to say all, and this will map all partitions on the table to one file group. Now this is really handy when you're initially setting up and testing, but I wouldn't recommend this, say, in a live environment because it doesn't give you that flexibility. I would always recommend specifying individual partitions for your partition scheme, at least initially, so you have the ability to move your partitions between file groups. Okay, so we've picked our partitioning key, we have our partition function, we've built our partition scheme. We can now build our partition table. And building a partition table is exactly the same as a normal table, with one exception. Instead of specifying a file group that the table goes on, we specify the partition scheme and then our partitioning key. So if we have a look at this table, it's a pretty simple table. We have an ID int identity column, column A with some data, column B with some data, and then a created date. And that created date is going to be our partitioning key. So this table is going to be partitioned by date. Okay. So let's go ahead and let's go through the first demo of building our partitioned table. So got Management Studio open here, and I'm going to build a database with, if I can find my mouse, there we are, with a whole bunch of file groups in it and my log. So let's just execute that. Excellent. So I have my database with a whole bunch of file groups that I'm going to use to build my partition table upon. Scrolling down, first of all, let's create a partition function with a left range type and the scheme. So I'm building a table here, and here are my initial partition boundary values. 1st of the 1st, 2011, all the way up to the 1st of the 1st, 2017. So this table is going to be partitioned by a date column, and the partitions are going to be by year. So let's create that, and I've I've got my file groups in my partition scheme here as well. There we go. Execute. Excellent. Okay, and now I can build my table. And this table is exactly the same table as in the slides. Got an ID int identity column, column A with some data, column B with some data, and my created date, which is my partitioning key. Let's create that. And now we can have a look at that partitions using this query here. Boom. And there are my partitions. So I have 8 partitions with their boundary values, no data in it, but we are all set. However, I used a left range type for my partition function. So let's have a look at the destination of any data that I'm going to insert. And I can do that using this $partition function. And what this allows me to do is say $partition dot my partition function and then some data. And this will tell me the partition that my data will be inserted into. So I've got the 1st of the 1st, 2011, the 31st of the 12th, 2011, and the 1st of the 1st, 2012. Let's have a look at which partitions they're going to end up in. Okay, so I have the 1st of the 1st, 2011 in partition 1, the 31st of the 12th, 2011 in partition 2, and the 1st of the 1st, 2012 also in partition 2. So partition 2 is going to contain data from 2011 and 2012. So I don't really want that. That's going to be a little bit confusing. I like to keep things simple so I can think in my head, okay, one partition, 1 year's worth of data. So let's actually blow all that away and rebuild using a right range type. Exactly the same. That's all I'm changing. Let's go. There we go. And now let's recheck the destination of that data. Aha, okay. The 1st of the 1st, 2011, partition number 2. The 31st of the 12th, 2011, also in partition 2. And the 1st of the 1st, 2012 is in partition 3. So partition number 2 has 2011's data in it, 1 year's worth, and partition 3 will have 2012's worth of data in it. So 1 year to one partition. And that, for me, makes it a lot more easier to understand in my head. So I'm going to leave it like that. And let's fire in some data. And this is just a little script to insert a load of random data into my table. Excellent. And then we can recheck my partitions. Aha, okay, I've purposely left these two empty, but we have 5 partitions here with a whole bunch of data in them. So that's looking pretty good. We've gone ahead and we've picked our partitioning key, which was my created date column. Let's have a look at the table. Do a refresh. We've got my partitioning key. And if we come down, we can have a look at storage. We've got my partition function, partition scheme, and we've inserted a load of data as well. So that's great. We have our table. But what we've essentially done is built a partitioned heap. There we go. I just got a flash up that my audio went. Was that all good?
Yes, I hear you just fine.
Thank you. Sorry, it just flashed up. My audio went, so I just wanted to double check. Okay, great. So we have built a partitioned heap, which is great. We can perform all the same specialist operations on a partitioned heap that we can a partitioned table with a clustered index on it. We can do the split, we can do the switch, we can do the merge, but we're essentially going to have the same problems that are inherent to heaps, forwarded pointers and such like that. So we want to put some indexes on that table. So first thing we want to do, put a clustered index on that table. And there are a couple of things we need to be aware of when applying indexes to a partition table. And with clustered indexes, we need to decide whether our index is going to be unique or non-unique. If it's unique, the partitioning key has to be explicitly specified within our index create statement. If it isn't, the create statement will fail. If it's non-unique and we don't include the partitioning key, SQL will add it explicitly in the background. It won't tell us it's doing it, but it's happening in the background anyway. So that's one thing we need to consider with clustered indexes. Now, this non-clustered index is an extra consideration, and that's whether our index is going to be aligned or non-aligned. An aligned non-clustered index uses the same partition scheme and partitioning key as the base table. So they are divided up the same, they are aligned. A non-aligned non-clustered index is an index that uses a different partitioning scheme or partitioning key or lives on a different file group to the base table. Now, You can do this. I've seen people do apply non-aligned, non-clustered indexes to a partition table. It's typically to try and dig themselves out of some sort of performance hole that they've dug themselves into. The one thing with non-aligned, non-clustered indexes is if you apply that to your partition table, you will lose the ability to perform the switch operation and therefore lose a lot of the power of partitioning. And the same thing with non-clustered indexes, whether they're going to be unique or non-unique. Excuse me. If they're unique, we have to explicitly specify the partitioning key in the create statement. If it's non-unique, SQL will implicitly add the partitioning key as an included column into our index. It won't tell you it's doing it, but it's happening in the background. So let's go ahead and have a look at applying some indexes, to our table. Close that. Okay, so here's our table. Some data in there, 8 partitions. And let's have a look at it again in here. We have, where are we? ID, column A, column B, and created date. Now this is an identity integer. So that could be a pretty good candidate for a unique clustered index. So let's go ahead and try and build that. So error it out immediately. Because it's a unique clustered index, we need to explicitly include the created date, our partitioning key, in our create statement. We didn't, and therefore our create statement has failed. So, okay, I'm going to be a bit bullheaded about it and say, I'm just going to make it a non-unique clustered index, and hit execute. Excellent. Run through this time, no problem. It's not unique. We didn't need to explicitly include the partitioning key in the statement. But let's have a look at what's happened in the background. So let's drill down into the data pages and see what's happened to our data. So the first thing I'm going to do is find a file. I'm going to pick file 5. Drop that there. And now I'm going to use dbcc ind, and on my partitioning demo database, my partition table, an index ID of 1, my clustered index, and that will allow me to see all the data pages that are assigned to my clustered index on my table. There we go, hit execute. But I'm looking for a page type of 1, data page ID of 56. Excellent. Drop that in there. And now I can use dbcc page to actually drill down and have a look at the data on that page and see what's happened to it. So let's drill down, have a look. Okay, and this is a load of metadata at the top. If I scroll down, here we go. We have slot 0, column 0. So this is the first record on the page, and I have a uniqueifier. This is standard SQL behavior. SQL will add a uniqueifier to all non-unique clustered indexes, whether they're on a partition table or not. So that's fine. We have our ID1, makes sense. That is our clustered. That is the column that we put our clustered index on. Sorry. Then look here. We have the created date column. Now, if this was a heap, the columns would have been in order that they are in on the table. So we'd have ID, column A, column B, and created date. But created date is there. Created date is here because it has been added to the clustered index in the background by SQL. It didn't tell us it was doing it, but it's actually physically changed the structure of the data on disk because we've applied a non-unique clustered index to a partition table. So we just need to be a little bit careful about what's happening in the background here. So that's something to be aware of when clustered indexes are being applied to a partition table. Let's have a look at a non-clustered index. I'm going to drop the clustered index and just create a non-clustered index on column A. Let's have a look. There we go. It's not unique, so we're all good. And let's drill back down in as well. Let's have a look at the data pages assigned. So dbcc ind, database, table, index ID of 2. And I'm looking for page type of 2, index page ID of 48. So 5. And let's drill it. Okay, get a different output this time. Here's our index column, but hey, look at this. SQL has implicitly added the created date as an included column to my index. Didn't tell me it was doing it, but there it is. And the only way I saw that was to drill down and have a look at the data on the page. Now, the reason I mention this is the fact that when you perform the switch operation from one table to another, you have to have the same structures on both tables. And that means having your indexes exactly the same. Now, if you switch into a non-partition table, which you can do, and something like this has occurred, your switch will fail because the index on the partition table will not match the index on the non-partition table. And you'll spend a lot of time head scratching and wondering what's going on. Now, there is a nice, easy way to prevent this type of thing happening, and that is to make your index, your clustered index, your partitioning key. And this will basically add your partitioning key to all indexes, and this won't come and get you in the background. So I'm going to drop all the indexes I've just created, and I'm going to create a unique clustered index on my partitioning key, and I'm going to make it unique by adding in my identity integer. I don't want SQL adding that uniqueifier on a non-unique index. I'm a bit of a control freak. I like to control it myself. So I'm going to drop that in. There we go. And I'm going to recreate my non-clustered index as well on my column A. Excellent. So that is indexing on a partition table. Jumping back into the slides. So we've got our table, we've got our indexes. We can now start looking at the specialist operations that we can apply to individual partitions on the table. And let's start with the merge and the split. Now these do pretty much exactly what they say on the tin. Merge effectively removes a partition by merging two partitions into one. We drop a boundary, merge the two partitions into one. This is a metadata only operation if it is performed on an empty partition. If it is not an empty partition, SQL will need to read the data to work out where that data now lives. These operations take a schema modlock and can cause severe blocking on your system. So you need to be very careful how you apply these operations to your table. Really, really simple syntax for the merge. We literally just say alter partition function and the partition function name, merge range, and then we pass in a boundary value that we want to drop. Hit execute, and hopefully if all's gone well, it's pretty much an instantaneous metadata only operation. Okay, that's the merge. Let's talk about the split. Again, exactly what it says on the tin. This creates a new partition based on a boundary value that we pass into it. Of course, the boundary value must be distinct from all other boundaries on the table. You can't have a duplicate boundary value. Again, this will take a schema modlock on the table. So we need to be careful, as this can be a metadata only operation if the partition that we're splitting from is empty. If it's not empty, SQL will need to read the data to ensure which side of the new partition, the data now lives on. And if it's going to hold that schema modlock, you can end up with a severe amount of blocking on your system. Really simple syntax again. We say alter partition scheme, give it a name, next use file group, because we need to tell SQL where our new partition is going to live. And then we just say alter partition function, name, split range, and pass in our new boundary value. So, that's not what I want to do. I want to do that. There we go, jumping ahead of myself. Let's go ahead and let's start merging and splitting some partitions. Okay, so let's have a look at my partition table. Okay, so we have an empty partition here with the 1st of the 1st, 2011. Let's get rid of that partition. So I'm going to use set statistics IO on, and this is going to show me if SQL has to do any IO work when I run my next statement. So I'm going to see if SQL does any IO when I run this statement. Hit execute. Oomph. Empty partition. No IO. We're all good. Pretty much a metadata only operation. Let's have a look at those partitions. Something odd has happened here. I dropped the partition boundary for this partition, didn't I? No, not really. This is this nasty little gotcha I mentioned earlier in the session. this boundary value here does not belong to this partition. It actually belongs to this partition. So when I said drop the 1st of the 1st, 2011, I was actually dropping the partition mapped to file group data 2. And then any data that was there would have been merged into it. And this can be particularly nasty, and I'll show you now, because I'm now going to merge this partition. It's empty, right? So I'm going to drop that boundary value, and we'll see what SQL does. Aha! It's had to do some work. So let's go back and let's have a look at those partitions. Still there. So what happened then was I dropped the partition that was mapped to file group data 3, and SQL merged that partition's data into this partition here. So we need to be very, very careful when we're merging partitions thinking they're empty, because that can catch you out. It's caught me out more times than I can think, actually. So the general advice is, if you're working with this, have at least 2 weeks of empty partitions, or say 14 empty partitions if you're doing it numerically, so that each time you run your merge operation, you can be confident that you are running this on an empty partition. Okay, so we've got 6 partitions here. Let's go ahead and let's split off some new partitions from here. So let's create a partition with a boundary value of the 1st of the 1st, 2018. So set statistics IO on again. Telling SQL it's going to live on data 9, because that's the next file group, and passing in the new boundary value. Excellent. No IO work done. And let's have a look at those partitions. Excellent. There is my new partition with its boundary value. So that was empty. Let's fire in some data and have a look at what happens when I run a split that has to read some data. Oop, let's do that. So just firing in some 500 records, having a look at the partitions again. And we've got a whole bunch of data in here now. So let's split off a new partition with a boundary value of the 1st of the 1st, 2019, and see what SQL does. Oh, yep. Sorry. Alter partition scheme, next use data 10. It's the next file group. And then we're going to split off. Aha. SQL's had to do some work. Okay, it hasn't had to do a lot of work because there's not a lot of data there. But the fact that it's had to do some work is cause for concern. Let's have a look at those partitions again. Okay, so we have our new partition, and SQL has had to read that data in the old partition and work out which side of the boundary all the data lives. So again, same with the merge, I'd recommend having 14 empty partitions at the end of your table as well, so that you're always confident that you are splitting off empty partitions, and SQL won't have to do any work, won't hold a schema model lock for a long time, and you won't end up with a load of severe blocking on your system. And setting up for the next demo, just going to show you a little function here. The SQL Server 2016 gave us the ability to truncate an individual partition. Now, this can either be a really, really good thing or a really, really bad thing, depending on your point of view, because I kind of like this for demos. I don't think I've ever run this in production because I'm far too paranoid that I'm going to get that number wrong. But setting up for the next demo, partition 7 gone. There it is. And then finally, getting rid of the next one. Let's have a look. Excellent. Got my empty partitions there. We're all good to go for the next demo. So that is splitting and merging. Now we can talk about my favorite operation, which is the switch operation. Now, I really, really like this operation because, again, it does exactly what it says on the tin, but it allows us to move a partition and its data from one table to another pretty much immediately as a metadata only operation. Now, there are some caveats to this. Both tables must have the same structures, so they have to have the same columns, same indexes, and they have to live on the same file group. Now, that means the partition that we're switching from to the partitions that we're switching to lives on the same file group, but we don't have to switch to a partition table. We can switch to a non-partition table. And if we do that, the partition table must live on the same file group as the partition we're switching from. Another thing, that the destination partition or table must be completely empty. We can't have any data in there, otherwise the switch will fail. Really, really simple syntax. We just say alter table, our source table, switch partition, and then our partition number. So say I want to switch partition 1 to our destination table if it's not partitioned. If it is partitioned, we then say partition and then the corresponding partition that we wish to switch our data into. So let's go ahead and let's go and switch some partitions in our database. So, okay, let's have a look at our table here. And let's get rid of this 195 records in our oldest partition. Say they've gone past our retention policy, we want to get rid of them. We want to archive them, otherwise we could just truncate the partition, but we actually want to retain these records. So we want to build an archive table that can hold those records for us. So I'm going to have my switch table here, and it is going to be exactly the same as my live table, same columns with my same indexes, but it's not going to be partitioned. It is just going to be on the same file group as the partition that I wish to switch from. So let's go ahead and create that. And I should have my two tables, same columns, same indexes. Excellent. Okay. And now I can run my switch statement. 3, 2, 1. Excellent. And let's have a look at my table. Gone. Okay. Check the switch table just to be sure. And there are my 195 records, switched pretty much instantaneously from my live table into my switch or my archive table. Okay, now I'm pretty sure everyone's had this happen to them where they've had a retention policy, they're moving data out, and someone said, oh, actually, we want to retain data for longer. That data that you've moved out of your live table, can you put that back for us, please? And I've sat there and I've gone, yeah, sure, not a problem. Gone back and said, okay, let's run our switch. Alter table, my switch table. Switch my partition 1. There's no partition 1, but it doesn't matter. To my partition table, my live table, and partition 1, back to where it originally came from. Not good. Okay, why has that happened? Let's have a look at the table. Now, I am trying to switch data into a partition that has an upper limit of the 1st, 2013. No data can go into that partition that equals or is above the 1st, 2013. So, but SQL doesn't know that the data that I'm trying to push in there matches that criteria. So I need to do something to tell SQL the data I'm switching from my switch table to my live table will fit into that partition. And the way I do that is just by adding a constraint to it. So I just say alter table, add constraint, check, create a date is less than the 1st, 2013. Add that. Nope, still got IO. And now I should run my switch. Okay, I've got a warning here that the partition 1 for my switch table is ignored because it's not partitioned, but my data is gone. And if I check my data is gone from the switch table, and it is back in my live table. So if our retention policies change, we can easily put back our data from our switch table to our live table just by adding a nice little constraint there. Okay, so let's have a look at combining all those specialist operations, the merge, the split, and the switch into what's called a partition sliding window. And this is just a method of extracting old data out of a table and importing new data in on a rolling basis. Now, we typically do this wrapped up as a stored procedure with a whole bunch of checks in it, but I'm going to step you through each one of the steps manually and show you how the partitioned table rolls forward so that we end up with the same amount of partitions that we did at the end, but they've moved forward one by one. So for our demo, they'll have moved forward by, say, a year. Not messing around, let's go straight back into a demo. Okay, so we have our partitions, all of them here with their data. I'm not going to use my switch table. I'm going to create a separate archive table on data 1. It's the same as the switch table, not partitioned. I'm also going to create a staging table on data 9. Again, not partitioned. So let's have a look here. All my tables, there they all are. All exactly the same. Same indexes. And now let's quickly switch out our data to our archive table and check that's successful. And now we can get rid of this partition. Now I'm about to make a mistake here. I'll show you. I thought I was merging an empty partition. But what I've done is drop data 4 and merged its data into data 1. That nasty little gotcha came back and got me again. So you need to be very careful when you do it. It's very easy to do. But okay, we've now merged that old partition. So let's go ahead and split off a new partition. First 2020 on data 11. Having a look. There it is. So now let's load up our staging table with some data and switch it into our live table. So little script here just to insert 250 rows into my staging table. And then I need to apply a constraint to my staging table so that it will fit into that partition. So I'm going to say the create date is greater than or equal to the 1st of the 1st, 2018, and less than the 1st of the 1st, 2019, and is not null. SQL won't know how to handle the nulls. If you try and do it with a switch, it will fail. So if you add the nulls in as well, there we go. Have a look. So we're going to get these 250 records into this partition here, hopefully, and switch out the data. And there we go. 0 rows in my staging table, and my 250 rows into my live table. So I've loaded up my staging table and instantly switched that data across. So I haven't got like a looped insert hitting my live table at any point. I've instantaneously brought that data across in a metadata only operation. Okay, and that is sliding windows. There we go. Just keep an eye on the time. Okay. So final section, just want to talk about file group restores. As we split our partition table up with individual partitions on individual file groups, in the event of a disaster recovery situation, we can only restore the file groups that we need and bring our live data online. So this can be useful for very large databases, can be used for restoring live partitions for a development environment. You need to be a little bit careful with this because all is not what you see when you do this. We are only going to restore the live file groups, and so only that data will be available. So you need to be a little bit careful whether or not that older data is needed. I have had to do this in the past, and when I have done it, what I've done is side-by-side restores and then copy the data across. There's only a few million rows, so it wasn't too much of an effort just to write that select insert. So again, no messing around. Let's go straight into a demo. Okay, so let's make sure I haven't already backed this up. Excellent. So first things first, I'm going to take a full backup just in case this demo goes horribly wrong. There we go. And let's have a look at our data. Okay, there's our table. This is going to be our live partition, and something disastrous is going to happen to those 250 rows. So first things first, we need to take a backup of all of our file groups. So use master and one by one, just specifying each file group with that keyword there, file group. Hit execute. And there we go, and they should all be there. And as this is production, we'll be taking transactional backups as well. And then back there. So we have a backup of all of our file groups. Something disastrous is about to happen to those 250 rows. That disaster is a Welsh DBA who's gotten his partition number wrong and has it execute on a truncate statement. Coming back, let's have a look at it. Data is gone. Okay, we need to get that back, and we need to get that back fast. So let's start off by taking a tail log backup. Putting the database into recovery. Why is that? Oh, hello, Management Studio. There we go. Excellent. And now we can restore the primary file group and the one file group that we need that has our data in it. Now, we always have to restore the primary file group, and this is a case for always keeping your primary file group as small as possible. If any of you out there that use Query Store is probably one of my favorite features of SQL Server, but guess where it stores its data? Hopefully that'll change in the future. But we'll restore our primary file group, and then the file group with our data on it. And then any transaction log backups. And now we can recover our database. Excellent. So let's have a look at our partitions. Hey, our data is back. But things aren't always what they seem. If we try and selecting that data, hit execute. Oh, I get a warning here. I haven't restored that file group. So that's why. I mean, I've got my 250 records, and the reason I'm getting an error there is because of this. I was referencing a partition boundary of a file group that hadn't been restored. If I took it back one and just referenced the partition boundaries within my partition that I restored, I don't get the error and I get my 250 records. If I try and select from a partition I haven't restored completely, I get an error telling me that the partition is offline, hasn't been restored, and I get none of the data back. That data is not available to me. So when I have done this in the past, I haven't replaced the live database because older data was needed. I've done a side-by-side restore, brought the file group online with the partition's data that I'd had an issue with, and then just brought that data across. It is a handy little bit of knowledge to have in case you ever have to want to reduce your recovery time in case of a disaster on a partition table. So, okay, that is pretty much all of the session. Just keeping an eye on the time. I do want to mention a quick story now. What's going on with that slide? There we go. So this happened to me in March this year, I think. It was, a friend of mine had implemented partitioning on a table and hadn't implemented any maintenance of it. So he'd had all his initial partitions and data was being inserted. It was partitioned by date. And after, say, about a week, one of the partitions ended up with all the data in. So he had one gigantic partition with millions and millions and millions of records in it. And it was a Friday and he pinged me around 2 o'clock in the afternoon and said, hey, how do I deal with this? Can I split this off? What can I do? And I said, well, as long as you know that the boundary value you're going to pass into your split statement isn't going to traverse any data, it's going to be above all your other data, it will still be a metadata only operation. You can hit that. Okay, you're going to create a gigantic partition, but then you'll be able to start splitting off new partitions and we can deal with that another time. And he said, no worries, Andrew, thank you very much. And I didn't hear from him the rest of the day. Till about 7 o'clock in the evening. We went, hey, fancy a pint? I went, yeah, no problem. I live in Bray. There's a brilliant little place down the seafront called the Porterhouse. Really nice selection of beers. Trundled down there, walked into the pub, found him in a corner, sitting with his laptop and a pint. And he looked up at me and went, you ready to do this? I went, ready to do what? I went, implement partitioning on this table. I said, you want to start implementing a partitioning solution on a production database on a Friday at 7 o'clock in the evening in the pub? And he looked at me and went, yeah, welcome to Ireland. So, okay, no bother. Sat down with my pint, started looking at the scripts, went to implement all these, went to start splitting off his gigantic partition, and then we'll have a look at splitting off more and more partitions. So we got the initial statement. We knew that the value we were passing in wasn't going to mean any data was going to be read. So we hit execute, and it failed immediately. Didn't even start reading data, read everywhere, failed. And the problem was I'd forgotten, or probably that I just didn't remember. Yeah, just didn't remember, is that he had a column store index on that table. If you have a column store index on a partition table, you cannot split off a non-empty partition. Microsoft's official advice is to drop or disable the column store index, switch out split off your partitions, and then rebuild it. Not the greatest advice for us. It's now 8 o'clock in the evening in the pub. So we had to come up with a different way of splitting off these partitions. And the solution that we came up with eventually, as there was no dev environment, so we had to go and build that, was to open a transaction, switch the data out to a staging table, split off all the partitions, switch the data back, and then close that transaction. And we went and we tested. It's getting on a bit now. It's about 9:30 in the evening. I'm actually having a great time. This is kind of cool for me. My friend, Colin, he's looking a bit stressed, if I'm honest. But we built it. We tested it in a dev system. We went to execute it in live, and it worked first time. Opened up the transaction, switched the data out, split the partitions off, switched the data back in, closed the transaction, job sorted. And I was really, really pleased with it. I was pretty chuffed with that bit of work. But I'll always remember the next thing he said to me. And he looked at me and went, that's great. 1 table down, 4 to go. We were there until about midnight, but we managed to get it working. And the moral of the story is if you have a column store index on your table, please be aware that you cannot split non-empty partitions. Okay. There's some resources for you. So there's the GitHub link, DBA from the Cold Digital Partitioning, that has all the slides and the code for the demos like today. And the link below there is a summary on my blog for every single partitioning post that I've written. Some of which I've based this session on, some of which go into a little bit further information. You're more than welcome to check those out. Do we have any questions?
You know it, Andrew. We have 2 questions.
Yep.
How can you back up only specific partitions, or can you?
Not specific partitions themselves, just the file groups that they're on using the file group keyword.
All right. And the other one is, can the source table also be unpartitioned in the case of a switch partition?
Yes. So you can, as it's basically the same as me switching back. It will ignore the partition number that you pass in, but yep, you can switch into a partition table. You can switch from a non-partition table into a partition table. You just need to be aware that you probably have to put some constraints on there to tell SQL that the data you're switching does fit into your destination partition.
All right. I do believe that is it.
Okay.
So thank you very much, Andrew.
Thank you very much. Really enjoyed.
Thank you very, yeah, I'm going to say thank you too. So it was an awesome presentation. I wanted to make sure to mention to everybody, check out DBAFund.org for all of our contact information and upcoming meetings. We do have another 1 or 2, I should know off the top of my head, but I don't. So this year, and then we already have through May booked for next year. So definitely check out everybody's upcoming topics and sessions. Also, check out DBAFundtube.org. That is our YouTube channel. And this presentation, along with our past ones, all the way back up to like 2016, are on there, so you can check it out for some great content. Make sure you're checking us out on Twitter. We are at DBAFun. I believe that's the Twitter handle. I'll look it up while I'm talking. But we do Fundamentals Friday, where we actually bring out one of our YouTube channels, YouTube presentations, and kind of mention it. So check that out. We also post all of these sessions in Twitter as well. If you have any kind of questions, let us know. Otherwise, thank you everyone and have a wonderful day.
I'll end it for you, just to be sure.
Yeah.
Thanks again, all.
Thank you. Nice meeting you.
Thank you. Thanks, Andrew. And I love that story at the end. I don't know what I would have said if you said, that's one down.
I would have,
Yeah.
what? It was easier after you got rid of the column store.
Yeah, but you don't know what else is going to come up. It could be something else. I don't know.
Never.
But that
You know it's going to be something new each time.
We were there till the early hours sorting that one out. It was good fun. It's always fun when it's not your production system.
Yeah, it's a lot
Amen.
less stress. Okay. Talk to y'all later. Thanks.
Okay.
Thanks for a great session.
Good.
Mm-hmm.
Let's see. Trying to find something before I actually cause it to go.